Today we're going to learn about factorial designs. This is kind of the final lesson in terms of these general linear models. We've gone over the ANOVA and then the ANCOVA, and now we're moving on to factorial designs, or also known as a two-way ANOVA. Um, Factorial designs are basically called that based on having multiple factors, and by factor we simply mean an independent variable. So what's different about these kinds of models or these types of statistical analysis is they have more than one independent variable. So it allows us to test more than one thing at once, and that's what makes factorial designs unique. So more than one independent or predictor variable is manipulated in these particular experiments. You can have a number of different independent and predictor variables if you want. So two-way ANOVA, two independent variables, three-way ANOVA, three independent, four-way, four independent variables, so on and so forth. So it allows you to have several different independent variables that you're analyzing all at once. In an independent design, that's when each group is different. So there's different entities in all of the conditions. The repeating measures design means that the same entities are in all conditions, meaning that each person goes through each of the three different kinds of conditions. And then a mixed design is when you have a little bit of both. You can also do the same sorts of things in terms of your post hoc tests as well. So depending on how many levels of the independent variable that you're looking at, it allows you to do something with that as well. And I'll kind of talk a little bit about that too. So let's go ahead and start with an example. This is called the beer goggles effect, and it looks at two different things. So the dependent variable is the median rating of attractiveness of 50 photos on a scale from 0, pass me a paper bag, to 10, pass me their phone number. I guess that's a little bit mean. Sorry about that. Anyway, they rank these photos, these 50 photos on a scale of 0 to 10 in terms of how attractive they were. Now the variables that were manipulated were, one, the amount of alcohol. So you either had a placebo of a non-alcoholic beer, then you had a low dose of alcohol, and then a high dose of alcohol. Finally, there were pre-ranked or pre-rated photos based on either being attractive or unattractive. So that's the basic setup. We can look at this in JASP as well. So let's go ahead, and this is, if you go to, I can show you this really quick. This data set is in the data library. If you look under the ANOVA, you go into beer goggles, that's what you need to do. There's a few things that we want to add. There's a few things we want to change with this data set. So first off, the attractiveness is currently an ordinal. Let's go ahead and make that a scale. We're going to assume it's scale from 0 to 10. Makes pretty good sense, seeing those kinds of terms. Now the other thing is we have ones and zeros here for face type. So what I want to do to help with our plots that we do, or our graphs, is let's go ahead and label these. So 0 is going to be unattractive face, and then 1 is going to be attractive face. Okay, so that adds that into our data set, makes it look a little bit better. Same thing with alcohol. I'm going to go ahead and change alcohol. So 0 will be placebo. Number 1 would be low dose. And then number 2 is going to be high dose. Okay, so that gets our data set fairly set up to the way we want to do it. So let's kind of return to our PowerPoint. Okay, so in addition to looking at the two independent variables, in this case the amount of alcohol and the attractiveness of the photos, we can also look at interactions. Interactions show how the effects of one predictor might depend on the effects of another. And the interaction effects are often sometimes more interesting than the main effects. And what it means is that there's some sort of the unique interaction between these two variables produces either an unexpected or an interesting type of an effect. And that's what we're looking for in these kinds of cases. So your outputs for your two-way ANOVA, which is what we're going to be doing today, or your factorial designs will be looking at what are the main effects, which will be your two independent variables. And then finally, you'll also be looking at an interaction effect, which sees if there's anything unique that happens by simply bringing these two types of variables together. This shows kind of the difference in interactions based on the plots. If you notice on the table here on the right, notice how the variable is basically doing the same thing for both the placebo and the high dose. So in this case, there's no real interaction happening. However, if you'll notice, in this case, there's a crossing of the lines. And what that crossing of the lines means, or when it looks like when the lines aren't a parallel, it's often the case that there's some sort of interaction effect. And that's what we'll often see in our plots, is we'll see some kind of overlap between the two variables. Okay, so the way that this is set up is just like the other ANOVA. Now, if you'll remember, in terms of just a one-way ANOVA, we're simply looking at sum of squares model and comparing that to sum of squares residual. Okay, this is your basic kind of one-way ANOVA. So what we're doing is we're simply breaking down this sum of squares model into more effects. So we have the sum of squares A, which refers to your first independent variable, your sum of squares B, which refers to your second independent variable, and then your sum of squares A times B, which is this kind of interaction effect. Now, if you look at these notes, it goes into some of the math behind this. I'm not expecting you to know this at this point, but what I do want to talk about is how the factorial ANOVA accomplishes this. And what it does is it creates different groups based on what variable is being analyzed. So for example, in terms of the attractive versus unattractive faces, what it does is it pools together all the scores based on those who were exposed to the attractive face and those who were, those who were exposed to the attractive face and those who were exposed to the unattractive face. So it basically takes all the data and makes two groups out of it. Now, for the sum of squares B, or the sum of squares for the second variable, which is going to be the amount of alcohol that was drank, notice how this is now taking this in terms of three groups. So I've taken all the data and now I've created three groups, and this is the group that had the placebo, low dose, and high dose. And that's the way that a factorial analysis works, is it creates different groups and compares those groups based on what independent variable is actually being looked at. Okay, so let's go ahead and take a look at the data here for the ANOVA, for the two-way ANOVA. Okay. So for ANOVA, we're still going to do the same type of ANOVA that we did before. And then our dependent variable is going to be attractiveness. And then our fixed factors is going to be alcohol, and it's going to be face type. Okay? So that creates these two independent variables that we're going to be looking at. So let's go ahead and look at the data straight away. So notice how on the left-hand side of your summary table, we have alcohol, face type, and then alcohol times face type. So these are your two main effects, alcohol and face type. And then this is your interaction effect, which is alcohol times face type. Okay? So notice it shows me the F values, the P values for each. Let's see, for each one, and all three of these were actually significant. Okay? So that's the starting place for what I'm going to be looking at. Now, secondly, let's go ahead and look at our plots here really quick. Now, the first plot we can look at is, let's just look at the differences in terms of alcohol. Now, if we notice here, we'll already notice this kind of trend between, it seems to be the case that persons ranked the pictures in terms of attractiveness lowest for the placebo. And then as the amount of alcohol goes up, they began to rank the faces as more attractive. So the general trend you're seeing is the more alcohol you have, you tend to perceive more pictures as being more attractive. So that gives us one look. Now let's also look at the face type. So when we look at face type, we bring that one in. Notice how overall persons ranked the attractive face as more attractive than the unattractive face. Okay, so that variable seems to have an effect as well. Notice how there's more variability in the unattractive faces here than the attractive face. The more closer your confidence intervals are to the mean, that means there's less variability within that particular group. Okay, so now let's go ahead and, let's see, take this back. Now let's do both together. So we'll take alcohol, and then we'll have separate lines based on face type. Okay, and then there's our plot. So notice here we have a crossing, okay? Notice that there's a crossing here between the unattractive faces and the attractive faces. So the attractive faces stayed about the same. There was actually a dip here at the end, whereas the unattractive faces simply went higher and higher the more alcohol that was consumed, to where ultimately, and because of the overlap that's happening here, basically by the time you have a certain amount of alcohol, you are no longer making any real distinctions between attractive versus unattractive faces. You tend to see everything as being attractive. And that's the role that alcohol plays in that kind of situation. Okay, so that indicates, the graph or the plot indicates that interaction effect we've been talking about. We've got the three different cases here. Let's see. So let's do, for contrasts. Now, one thing to remember is, remember face type, there's only two. There's only two types of faces. So there's no real need to do any kind of contrast. If there's a significant difference, then we just have to look at the means, and we'll be able to know which one is bigger. But we can look at alcohol and see if any of the contrasts work there. So let's do our basic one, which is the Helmholtz, which compares a placebo to any dosage of alcohol, and then low dose to high dose. And so notice that in terms of the overall effect that we're seeing, the main difference is between any amount of alcohol, whether low or high, and the placebo. Because notice how that one is the one that's most, that actually has, significant results. Notice how there's not that much difference between a low dose and a high dose, okay? Notice how that remains insignificant or above 0.05. So that tells us basically that it doesn't really matter how much alcohol you drink, but once you begin drinking alcohol, you begin to change your perceptions of attractiveness. So, finally, let's go ahead and talk through how to report our results. What we're going to need to report, or what we're going to want to report, are each of the main effects. So the main effect for alcohol and attractive versus non-attractive faces, or face type, and then the interaction effect, as well as our contrasts. And then, of course, we'll always want to include our descriptives plot with our descriptives plot with that as well. So basically, because we have multiple independent variables in the interaction effect, we have to report each of those. So we'll want to report there was a significant main effect of the amount of alcohol consumed on the ratings of the attractiveness of faces. I'm sorry, on the ratings of the attractiveness of faces. And then we have our F value, P value, and then our eta squared. And then because there was 3 levels of the independent variable of alcohol, we'll want to do a contrast. So in this case, did that the Helmert contrast, the Helmert plan contrast, and then we'll simply report that as well. Helmert plan contrast revealed that the attractiveness ratings were significantly higher after any dose, and that's where we go back and look here and notice that placebo was compared to low dose and high dose. So a single group was made out of the low dose and high dose. So the plan contrast revealed ratings were significantly higher for any dose of alcohol in comparison to the placebo. We write down that T value and then the P. And then the attractiveness ratings were not significantly different after a low dose compared to a high dose. That's where we go back here. Come back to our contrast. We look at that. Then we have our T value and our P value there as well. And then so then after that, we go to our second main effect, which were the attractive versus non-attractive faces. And then we'll remember that that was significant as well. So attractive faces were rated significantly higher than the unattractive faces. And then we write down our F values here for face type. F value here, 15. P value less than 0.001. We'll also include our eta squared there as well, which is at the end. And then finally, we'll want to report that interaction effect. So there's a significant interaction between the amount of alcohol consumed and the type of face the person rated on attractiveness. So there's our F values and our P value and our eta squared as well. And so then we just simply explain what that interaction effect is. It says this effect indicates that ratings of unattractive and attractive faces were affected differently by alcohol. And that's where we know, based on our plot, that based on the amount of alcohol that they had, there was a significant difference or an interaction between these two variables. All right, and that's it. So that's just an extension of the ANOVA into more than one independent variable. And we'll continue with something different next time.